Here we go through the comparative study of S block elements, that is first A group with the second A group and itself in its own groups from top to bottom, physical and chemical properties. First we'll take physical properties. In it, radii, density, ionization potentials, and solubility, reactivity, and several other properties are compared. First, we see that down the column nuclear charge increases and a new orbital is added to each alkaline earth atom. Ionic and atomic radii increases down the column of the periodic table. Both radii will be smaller than the alkali metal and larger than other atoms of the same period due to charge and addition of the electron to the same energy level. Alkaline earth elements can lose both as electrons and hence become doubly positive cationic. The cationic radii is smaller than the neutral atom. Still, the ionic radii increases down the column. For example, beryllium radii is less than magnesium, then calcium, strontium, and barium radii is maximum. Similarly, for ionic radii, beryllium ion is smallest while barium ion radii is maximum and barium ion is largest. But here we see on the basis of ionic radii how the alkaline earth metals are denser than the alkali metals. Here we see their comparative densities. Radii being smaller, the volume of the atoms are also smaller. In addition, due to the presence of two valence electrons, atoms have stronger metallic bonding. Hence, alkaline earth metals have more density and are harder than the alkali metals. Density generally increases from magnesium to radium, while calcium has the lowest density among the alkaline earth metals. Now we see the comparative ionization energies. Ionization energy. Alkaline earth metals can donate both valence electrons to get a noble gas configuration of octet configuration. Thus they have two ionization energies. First ionization energy and second ionization energy. First ionization energy of alkaline earth metals is the energy needed for the removal of the first electron from the neutral atom. It is larger than that of the alkali metal atom for two reasons. Due to the smaller radii and the electrons being held tightly by the higher nuclear charge and electron being removed from a fully filled and hence a stable subshell. Second ionization energy of alkaline earth metals needed for the second electron from the cation will be more than the first ionization energy of the atom, but less than the second ionization of the alkali metal. Here the alkali metal ionization energy is compared with the alkaline earth metal second ionization energy for the removal of the second electron from the ion. In spite of the high ionization energy, removal of both electrons are feasible because atom gets a noble gas configuration which provides stability to the atom. The smaller size and higher charge help to overcome the higher ionization energy by higher lattice energy arising due to the close packing of atoms or ions in solids. Higher hydration energy in liquids is due to their larger solvation. So group 2 alkaline earth elements are all divalent electropositive metals and exhibit a fixed oxidation state of 2. Ionization energy needed for the removal of the valence electron will be highest for the small beryllium atom. With increasing atomic size, the valence electron gets shielded by the inner electrons and becomes easily removable with less energy requirement. Hence, the ionization energy decreases with an increasing atomic number or atomic size. So, here is a comparative study of the ionization energies with the other group and also in the same group. So ionization energy of beryllium is highest, greater, and it decreases from through magnesium, calcium, strontium and up to barium. In the same period, ionization energy increases due to the decreasing the ionic size and increasing nuclear charge. Now we see the other properties physical like solubility, reactivity, flame coloration and their melting points and boiling points. Now we see first why solubility of alkaline earth metals decreases down the group. Comparative study of elements from top to bottom of the group. That is beryllium ion is the most soluble and the solubility decreases with increasing size so that barium ion is the least water soluble alkaline earth metal ion. Solubility in water is related to the ionic nature and their size. Now, smaller ions have higher charge density and can be solvated by more water molecules. This releases a higher enthalpy of hydration and makes the hydrated ions more stable. For example, solubility of beryllium ion is highest and decreases towards barium, that is solubility of magnesium is still less. Then from magnesium to calcium solubility decreases again. Then solubility of strontium and least for the solubility of barium ion. Now we come to the reactivity of the alkaline earth metals. Reducing ability is inversely related to the ionization energies. So now here we see that how these all properties are related and dependent on the atomic radii and the ionization energies. As ionization energy decreases down the column, reducing property is expected to increase from beryllium to barium. So likewise, as their sizes, atomic size, ionic size changes and their properties also changes. Reduction potential also decreases from beryllium to barium, indicating the increasing reducing capacities, but the alkaline earth metals are weaker reducing agents than alkali metals due to higher ionization energy. Now we see the flame coloration also changes, and that is how we experimentally identify them by their flame test easily. In alkaline earth metals, the energy needed for an electronic transition between the available energy levels falls in the visible spectrum region. So on heating, except beryllium and magnesium produces a characteristic color to the flame, reflective of their emission or absorption spectrum and can be used for their identification. For example, calcium gives brick red color, strontium gives crimson red color and barium that gives apple green color. So these characteristics color to the flame are induced and they can be identified easily. This is the specific property of the alkali and alkaline earth metals. Now we see the melting points and boiling points also vary for different elements because of the smaller size and strong metallic bonding in close packed structure. The melting and boiling points of the alkaline earth metals are higher than the alkali metals. Among the alkaline earth metals except for the magnesium, the melting point and boiling points decreases regularly from beryllium to barium. So these are the physical properties of alkaline earth metals compared to alkali metals and itself in the group both for the first A and second A groups of the S block elements.